S n minus 1, that's 2 minus 1 is 1. S tau prime of naught, right? Minus S tau of S. Is this correct? Yes or no? Okay. So this becomes, we're told that the initial condition is 0. That would be S squared tau of S minus S tau of S, like this. That's for that one. Yes, did I miss something?
Isn't it S and then S tau S minus tau prime?
Minus?
Like, isn't it supposed to be swapped? Isn't it supposed to just be tau 0 and then tau prime?
Oh, you're right. Tau 0 minus tau prime S. Is that what you're saying? Let's see the Laplace table. The one I gave you is much more clearer. Let's see. Yeah, you're correct. Question. Is this tau prime of S or tau prime of 0? This one. So this left with this because this is 0, this is 0. That's correct now, right? Okay, tell me what this is. Laplace of d tau over dt. That would be what? From the table. Someone tell me from the table. That would be S tau of S, right? Minus t of 0. Is that correct? So this gives S t of S. You do not need to memorize this. You just need to know how to use it in the table. Right. And this guy here, we're told that everything here, we're told that 5q of t is equals to 5q naught u of t. So when you take the Laplace transform of 5q naught u of t, that would give us 5q naught over s. U of t is u of s. We could just remove this because it's the same thing as saying f of s. So it could just be 5q naught over s. It's 5. Right? Okay, so we have everything we need now to solve it. So let's put them together. If we put them together, this becomes s squared tau of s plus 3. Most of you have solved this before. Plus 3 s tau of s plus 2 tau of s like this, because Laplace of t is t of s, would be 5q naught over s. If you like, you can put the u of s to show it's a Laplace domain or not. Don't confuse my 5 with s, please. If you have it, this is 5, this is s. They look the same, but they are not the same. So this becomes like this, right? S squared plus 3s plus 2 is 5q naught over s. So t of s becomes 5q naught over s multiplied by s squared plus 3s plus 2. Was this where we stopped the last time? Right? Okay, let me know if there's anything I missed here. Who has a colored marker? I myself am getting confused.
Yeah.
What is Laplace of q naught? 5q naught. What's Laplace of 5q naught? What's that? 5q naught is a constant, right? So that's 5q naught times 1. Laplace of 1 is 1 over s, right? So Laplace of constant and comma, that's 5q naught, Laplace of 1. That's 5q naught, Laplace of 1 is 1 over s. That's 5q naught over s.
Okay, thank you.
It's a constant. Yes, that's a good question. Okay, now let's factorize this out. So this gives 5q naught over s into bracket. That's s squared plus 2s plus s plus 2 like this. That becomes s plus s into bracket s plus 2 plus 1 s plus 2. That's what we have. I'm solving backwards. Okay. Do you have questions? Questions? Thank you. So that becomes 5q naught divided by s into bracket s plus 2 s plus 1. Okay. So I want you to tell me, how do I split this? How do I split this? Can I say, tell me if I'm right or wrong. Can I say this is A over S plus B over S plus 2 plus C over S plus 1? Can I do that?
Yeah.
Right? Okay, great. Because we're going to do some weird case study today. There are some very ridiculous questions we'll solve after this. S plus 2, S plus 1. Okay, so this gives us A into bracket S plus 2 multiplied by S plus 1, because A will take both of these, excluding the one he has, plus B into bracket S, S plus 1, plus C, S plus 1S. Okay. You can do it yourself too, if you know how to do it. So most of it does. When we expand this, that's A, this is S squared plus S plus 2S plus 2. That's S squared plus 2S plus 2. That's for A, right? Plus B is S squared plus S, right? Then C is S squared plus S also.
Professor,
I am missing something.
it's
2.
S plus 2 goes to
C, yes. Thank you. Please, if we make mistake, we all suffer. So if I make mistake, tell me. Because then I will not get the answer. Then you will be looking at me and I'll be looking at you too. Right? If I make mistake, tell me. Yes?
S squared plus 3S plus 2.
So it should be 3S, yeah.
Thank you. Which other one? So it's correct. So let's take S squared together. So we have AS squared. Let's do for S squared. If we do for S squared, we have A, right? Plus B, plus C. That's for S squared. And that would be 0 because this does not have S squared. This is just 5 Q naught. Let's do S. If we do S, that would be, for S is going to be 3A, right? Plus 3 plus B, which is BS here. Then plus 2C. That would also be 0 because we don't have S yet. Then let's do for the constant. Constant is 2A. Constant is 2A, which is this one. 2A would be, there is no constant here, there is no constant here. Would be 5Q naught. So A is 5Q naught over 2. Right? P,
yeah.
do you need me to write up?
No, it's okay.
Okay, A is 5Q naught over 2. Right? So since we find A, we can say A plus B plus C is 0. So B plus C would be minus 5Q naught over 2 because A is 5Q naught over 2. Right? And we also know that 3A plus B plus 2C is 0. B plus 2C would be minus 3A, which is minus 3 times 5Q naught over 2. That's minus 15Q naught over 2. So B plus 2C is minus 15Q naught over 2. Question. Okay. So I'll let you find B and C for me and tell me what it is. Using this equation. This could be equation 1, equation 2. And tell me. Is C. That would give us minus 15Q naught over 2 minus, then minus, we change this to plus. That would be plus 5Q naught over 2. If you do that, you would have C would be minus 15Q naught plus 5Q naught. That would be minus 10Q naught over 2. That's minus 5Q naught over 2. Did anyone get that as C? So C is minus 5Q naught over 2. Then we know that our B is minus 5Q naught over 2. This equation here, minus 5Q naught over 2 minus C.
Jude,
Yeah.
why is C over 2?
What do you mean?
It should, isn't 10 over 2 5 in that one?
Yeah, 10 over 2 is 5, minus 5.
And why is it over 2?
Sorry. Thank you. Minus 5 Q naught. Right? Okay, let's see. So that becomes minus 5 Q naught minus, is this correct? Yeah. Minus C. So this is plus, right? Let me see. Let me make it easier for all of us. From this equation here, our C would be minus 5 Q naught over 2 minus, sorry, our B would be minus C. Right? Because B plus C is this. So we know our C here, so our B would be this minus C. So that would be minus 5 Q naught over 2 minus, then this is minus C. This negative would be minus 5 Q naught like this. That would be minus 5 Q naught over 2 plus 5 Q naught. Right? Put up your hands if you think something is wrong here. That would be 10 Q naught minus 5 Q naught. That's 5 Q naught over 2. So we have our C, A, and B. So this is our C, this is our B, and this is our A. So let's go back to that equation and put everything together. Yes? You're raising up your hand. Zoe, I thought you were raising up your hand.
No.
Are you sure?
Yeah, I'm sure. Thank you, though.
She's protesting.
Okay, so our equation becomes A over S. Our A is 5 Q naught over 2. That becomes 5 Q naught over 2 divided by S. Let me use S in black, so we know the difference between S and 5. S is in black. Plus B over S plus 2. Our B is minus 5 Q naught. That would automatically change this to minus 5 Q naught over S plus 2. Then we have plus C over S plus 1. So that becomes plus C. Our C is 5 Q naught over 2. 5 Q naught over 2 divided by S plus 1. So let's find the Laplace inverse of this. Would be our answer. Our answer would be Laplace inverse of this. We need to move it to time. Yes?
I don't think the B term is negative.
This one here. Plus 5Q over 2. Right? Okay. Did everyone agree? So it's like this. Thanks. Any other one there is missing? A, B, C, can you check? Yes.
Shouldn't C not be over 2 and B be over 2?
Let's do it again. B is minus 5Q naught over 2 minus C. Right? From here. Okay. So B plus C is this, right? C is going to be minus 5Q naught. This is correct. Right? Because if you look at it, minus 15 plus 5 is minus 10. So this is correct. The problem is this one, B. And B is minus 5Q naught over 2 minus C. Right? Because from this equation here, so B becomes minus 5Q naught over 2 minus, we change to plus here. Right? So if you do that, that would be minus 10 plus 5. So this is minus 5 here plus 10. So that's 5Q naught over 2. So what's the?
In the Laplace inverse.
So B is 5Q naught over 2 and C is minus 5Q naught. I get what you're saying now. And this is like this.
Yes.
Okay. Any other one? Is there anyone that cannot do the Laplace inverse of this one? So let's start with this one. Can someone tell me the answer to this? What would be the inverse of this? Yes, Nina.
Well, inverse of 1 over S is just 1. So
Yes,
5.
it's 1. So it's going to be 5Q over 2. You're correct. Right? Because this is a constant. And 1 over S is 1. Right? How about this one? Anyone? Yes. Go ahead.
5q naught over 2
Plus, yes, 5q naught over 2
times e to the negative
e negative 2t is in t, because 1 over s plus 2 is negative 2t. Then this becomes 5q naught e negative t, right? So we can bring 5q naught out of it. We can bring 5q naught over 2 out. That becomes 1 plus e negative 2t minus 2e negative t. So this is the answer to the question. Okay, it's long, but it's worth it. Factor. That's what CSTR is. They are identical. They are arranged in series. And the first tank receives feed C in. So you have 2 tanks. You can have this one like this. And this is tank 1. And this is 2. They are in series like this, right? And it says this first tank receives the feed goes in. I need to buy more markers. You have C in is going in here. And both tanks follow this equation. So tau the C1 over dt plus C1 is C in a function of t. This is for tank 1. And tank 2 is tau the C2 over dt plus C1 is plus C2 is C1. You are asked to find the transfer function C2s over C in S. Okay. Get a ratio, because the ratio we're looking for is the inlet, which is this guy here, the Laplace domain of this, to C2, which is this guy here. That's the ratio we're looking for. Okay, question. So let's do this in the Laplace domain, right? The same way we're doing, tau is a constant, right? So let's say this becomes tau. Laplace of this is s tau of s, right? Minus tau of 0. Okay, that's the Laplace of this guy. So plus Laplace of C1 will be C1 of S, because we're changing it to Laplace domain. This one will be C in, instead of T, will be C in of S. That's that one. Can someone check this, if this is the correct formula for Laplace of the first order integral? This one. Is it correct? Okay, great. I have 5 markers and none of them are working well. Okay, so here, this becomes, are we given any initial conditions in the question? Are we asked to assume anything? No. So if we're not given any initial condition, we can assume initial conditions is 0, because this means at time t is equals to 0, there is no flow anyway. So this can be 0, this becomes tau s t of s plus C1 of s is C in of s, right? Okay, so let's do the second one. The second one is tau the C2 dt is equals to plus C2 is C1. Okay, question before we continue. Does anyone have a spare marker I could use? This df dt is sf of s minus f of 0. Right? So, thank you. So if you're doing Laplace of the C2 over dt, so our f is C2, right? And our t is t, that would be s, f is C2. C2 of s, right? Minus f of 0, that would be C2 of 0. Does that make sense? Class of the C1 over dt, again, could be SC1 of s minus C1 of 0. That becomes easier than using this one. So let's do it that way, so it becomes easier. So we can factorize out. let's do it that way. So this one becomes tau into bracket. So let's just put it here using this formula here that we got from that. This one becomes tau into bracket SC1 of S minus C1 of 0. Then plus C1 of S like this becomes C in of S. That's for this one. So what we did was we followed this formula and expressed it this way. Just replace F with C2, F with C1. That becomes easier. So if we do the same here, this one becomes tau into bracket. That becomes SC2 of S minus C2 of 0, right? Would be equals to what was there in the equation there. Let's see. The second equation plus C2 is C1. Plus C2 of S is C1 of S. So take a moment backward and look at this. And let me know if you don't understand. Because sometimes we get really confused if we're playing with numbers because we're used to T and Y. So this one is for equation 1 and this one is for equation 2. Okay. So from here, from equation 1, if you look at it, initial concentration is 0 from equation 1. So let's start with equation 1. So from equation 1, if initial concentration is 0, it becomes tau SC1 of S plus C1 of S is C in of S because this guy is 0. Initial concentration is 0 at time t is equals to 0. So that means you could bring C1 of S out. We have tau S plus 1 here is C in of S. That's what we have. Right. So our C1 of S becomes C in of S divided by tau S plus 1. So we can call this equation 3. Let's do the same for this equation. Again, C2 initial condition is 0. So we have tau SC2 plus C2 of S becomes C1 of S, like this. Right? Because this is also 0 at initial condition, time t is 0. So it becomes tau S, this is C2 of S. It becomes C2 of S, tau S plus 1 is C1 of S. So our C2 of S becomes C1 of S over tau S plus 1. So we can call this equation 4. Okay. So we have equation 3 and 4. The question is asking us to look for C2 over C in. How do we do that? Does anyone know? We have look at equation 3 and 4. The question is asking to look for C2 divided by C in. How do we do that? Does anyone know how we can do that? Yes? Yeah, you can put 3 into 4. That's correct. Because you have C1 here as everything. So all you need to do is replace C1 with this. If you do that, you can get the ratio. So you write, put 3 into 4. So if we put equation 3 into 4.
So we are actually finding C1 and C2, right? For initial concentration and final concentration, right?
Yeah.
Okay.
If you put equation 3 into 4, it becomes, into equation 4, it becomes, our equation 4 is C2 in Laplace domain, C1 of S divided by tau S plus 1. So instead of C1, it becomes, our C1 is C in of S divided by tau S plus 1. Then we divide it by tau S plus 1 like this. So it becomes C in of S over tau S plus 1 squared. That's C2 of S. But the question is asking us to find C2 of S over C in of S. So if you put this here, it becomes C2 of S over C in of S becomes 1 over tau S plus 1 squared. So that's the first part. All I did was bring this guy to this side. Okay. Now, the difficult question here is convert this to time domain. I want you all to try that. This is in Laplace domain. It's very tricky too. Laplace table you have is minus. If this is minus, you can. But this is plus. So when you expand this, it's tau s plus 1, tau s plus 1 like this. So we need to expand it. And when we do that, it becomes 1 over, this becomes tau square s square, right? Plus tau s, that's plus 2 tau s like this, plus 1. Okay, from here, who can tell me what we can do? Anyone? Yes, tell me.
Well, like a t squared from all of that.
Yes, you could do that because this r square, you could bring that, so it becomes 1 over, you could bring this tau square out, this becomes s square because we want this s square to be alone, so it becomes easier to solve.
Plus.
Right? Plus this becomes 2s over tau, right?
Yeah.
Then plus 1 plus tau square. No, sorry, 1 over tau
1 over tau square.
Yeah. Plus 1 over tau square like this. Now, you can factorize this guy here. You can factorize this. You can. Right, so this becomes 1 over, this is a constant now. Then you have 1 over s square plus 2s over tau plus 1 over tau square. Okay. Someone help me out. Do the factorization of this one. What do you get if you do the factorization? Those of you that have done it. Tell me. You have, if you factorize what is inside there, you get s plus 1 over tau square. Like this, right? Yeah, because when you do that, that's what you will get. Because if you expand this, you will get everything inside that. And then, okay, so this becomes 1 over tau square like this times, this is a constant, 1 over s plus 1 over tau square. Can we find the Laplace transform of that one? Right? Can we find it? If you do the Laplace transform of this guy here, you will get t exponential minus t over tau. So that becomes 1 over tau square, which is the answer there, t exponential minus t over tau. That's the Laplace inverse of this. Okay. Yeah. That is why most people were angry last year when I gave them this question in the exam.